everybody. Our first chapter is functions and the graphs. And the first section of the chapter 1 is functions. Before defining the function, I will give a brief review of the Cartesian coordinate system in the plane and the graph of the equation, and then I will start the concept of the function, which is one of the most important concepts in math. So let's start from the Cartesian coordinate system. Recall that to form a Cartesian coordinate system, which is also known as a rectangular coordinate system, we select two real number lines. One of them is horizontal and the other is vertical. One of them is horizontal and the other vertical. Let them cross through their origins as let's indicate here. I would like to change the color. So this is their intersection, and it is called as a origin. These two number lines are called the coordinate axis. Separately, horizontal axis and the vertical axis. Sometimes the horizontal axis can be called the x-axis and the vertical axis can be called as a y-axis. And right side of the horizontal axis is usually chosen for the positive direction. So this direction is positive direction. Then left side is negative direction. And similarly, upside is the usual choice for the positive direction, again for the vertical line or vertical axis. The coordinate axis divides the plane into 4 parts called quadrants, which are numbered counterclockwise from 1 to 4. Counterclockwise direction is direction. So this is which part is the first quadrant? When the x and y are positive, this is the first quadrant. So this is the first quadrant. In the counterclockwise direction, this part is second quadrant, this is third quadrant, this is fourth quadrant. Okay, so we numbered counterclockwise direction. Now we would like to assign the coordinates to each point in the plane. So given an arbitrary point P, let's choose, this is the arbitrary point P. We sketch the horizontal and the vertical line which are passes through to point P. So horizontal line, let's sketch the whole horizontal line, but rest part is not important, and the vertical line which is passes through to point P. So the intersection point of the horizontal line with the vertical axis and the which is that point, and the intersection of the vertical line with the horizontal axis is that point. So these 2 points describe our point P in the plane. How? That distances from origin to the point on the horizontal axis. Let's say this length is A, so this point called as A. And if this length is B, this point, which point? This point is called a point B. So the coordinates of the point P is A, B. So these two numbers, A and B, written as the ordered pair, A, B. That is okay. A, B are called the coordinates of the point P. Okay. The first coordinate A is called the abscissa. So this is abscissa. And the second coordinate B is called the ordinate. So that is the ordinate of the point P. So by this way, we can describe any point on the plane. So there is a one-to-one correspondence between the point in a plane and the elements in the set of all ordered pair of the real number. So when the ordered pair is given, you can address their point, you can find their point. When the point is given on the plane, you can find the ordered pairs. So briefly, I can say that the procedure we have just described assigns to each point P in the plane a unique pair of real number A, B, and conversely, if we are given an ordered pair of the real number A, B, then reversing the procedure, we can determine a unique point P in the plane. This situation is often referred as the fundamental theorem of the analytic geometry.